Let me help you with problem 7, assignment 4. 3 negative charges arranged in a square. We want to know the electric field at the center, right here. The potential and the electric field. Let's do the potential first. So if we call this Q1, Q2, and Q3, the sum of all the voltages are going to be V1 plus V2 plus V3. And notice that the distances are all the same. This is R1, this is R2, this is R3, and they're all equal to half the diagonal. So that's going to be the square root of 2 over 2 times the side. So we have 3, sum of all the voltages. Since they're all the same, it's just going to be 3 times any one of them. And one of them would be K, Q, over R, where R is the square root of 2 over 2 times S. In this case, it would make it easier to write this as 3KQ over S divided by root 2. You can convince yourself that that's the same thing. Then you invert and multiply, and the answer comes out readily. 3 times the square root of 2 KQ over S. Not too bad. Now when we go to do the electric field, let me redraw the thing. You can see that there's 3 vectors. Not very well drawn, but I think you can understand. Negative charges, 3 vectors, all the same magnitude, because the distances and the charge magnitudes are the same. So this E1 is going to add to E2 and add to 0. And so the net field, sum of the 3 fields, vector sum, writing it out, E1 plus E2 plus E3. Of course, quiz or assignment, you should write out that vector equation. Make the statement E1 plus E3 equals 0. This is just a nice clear way of writing it. That means the total sum is just going to be E2. And so in this case, that's going to be K, Q2, or just Q, we might call it, over S squared over the square root of 2 squared, which is 2. I'm just using this here and squaring it. And then we invert and multiply, and we get the answer. 2KQ over S squared. Of course, that's the magnitude. The direction, well, the direction's along a diagonal. So we'll just say it's along. All right, let's figure it out. It's going to be E, the sum of E equals E2. The 2 components are going to be sine and cosine of 45 degrees. So that's going to be equal to, I'm going to have to multiply this by the cosine of 45 degrees. That's the square root of 2 over 2. The 2's will cancel, and we'll be left with square root of 2 KQ over S squared I hat plus the same thing J hat. Shorter way to write it is just as I hat plus J hat.